Welcome to this another lecture of the course Computer Aided Power System Analysis. In this lecture we would be again continuing with our NRLF rectangular method. Now, in the last lecture we have defined the unknown as well as the known vectors. So, we are talking about unknown vectors. Unknown vectors are vector E and vector F, and known vectors are vector P, vector Q, vector V square, and we have already defined what these vectors are. So, then therefore, and now we have also looked into that what are the equations for this P, what are the equations for this Q, and what are the equations for this V, and all these equations are actually represented in terms of these unknown values E and F. So, then therefore, following the standard procedure of Taylor series expansion and etc., we can formulate the load flow problem in this case also in the similar way as we have done in the case of NRLF polar, as that we have got now unknown vector, that is delta E, delta F. So, these are the basically the correction vector. So, it would be delta E and delta F, and our mismatch vector would be delta P, delta Q and delta V square. Now, here we can see that our unknown vector has got actually two sub vector, and my known vector have got actually 3 sub vectors. So, then therefore, there are altogether 2 into 3, the 2 into 3 is equal to 6 sub matrices should be there. So, then therefore, we can write down that it should be J 1, J 2, J 3, J 4, J 5, J 6. All these are Jacobian sub matrices. How did we arrive at this? We are simply taking the case of this Newton-Raphson polar coordinate, where in that case we had this unknown vector delta theta as the delta V. So, then therefore, there were actually 2 unknown sub vectors, and we had got 2 known sub vector delta P and delta Q, and we have seen that connecting these vectors delta theta and delta V, delta P and delta Q are, there are 4 Jacobian sub matrices J 1, J 2, J 3, J 4. But here we have got 2 unknown sub vector and there are 3 known sub vectors. So, then therefore, there should be 2 into 3, that is 6 Jacobian sub matrices. Now, we also seen that delta E vector would be dimension n minus 1 cross 1, delta F vector would be dimension n minus 1 cross 1, delta P vector would also be a dimension n minus 1 cross 1, delta Q vector would be a dimension of n minus m cross 1, and delta V square vector would be a dimension of m minus 1 cross 1. So, if we have this dimension, so then therefore, automatically J 1 would be a dimension of n minus 1 cross n minus 1, J 2 would also be the dimension of n minus 1 cross n minus 1, this cross this, J 3 would be what is J 3? J 3 is actually connecting delta Q with delta E, and delta Q has got a dimension n minus m. So, it has got dimension n minus m cross n minus 1. J 4 is also connecting delta q vector with the vector delta f. So, then therefore, it also should have a dimension n minus m cross n minus 1. J 5 is connecting the delta v square vector with delta e. So, then it should be m minus 1 cross n minus 1. Similarly, J 6 also should have a dimension of m minus 1 cross n minus 1. Now, what should be the size of this Jacobian matrix? Now, this is a big Jacobian matrix. Now, according to our parlance, we say that this is a big Jacobian matrix. This is a Jacobian matrix J, big Jacobian matrix. This is the correction vector delta x, and this is the mismatch vector delta m. Now, let us look what would be the dimension of this matrix J, dimension of this matrix delta x, dimension of this matrix delta m. Dimension of delta is pretty easy. It would be 2 into n minus 1 cross 1, because you see this is also n minus 1, this is also n minus 1. So, then therefore, altogether there will be 2 into n minus 1 rows. This would have n minus 1 here, n minus m here, and m minus 1 here. So, then if we add them up, it will also be 2 n minus 2 into n minus 1. So, delta m vector also would be a size of 2 into n minus 1 cross 1, and matrix J would be a dimension of 2 into n minus 1 cross 2 into n minus 1. It is obvious, because if this has got a dimension 2 into n minus 1 and if this has got a dimension 2 into n minus 1. So, then therefore, this matrix J has to have a dimension of this cross this, it is obvious. But let us again cross check. So, J 1 has got a row n minus 1, J 3 has got a row n minus m, and J 5 has got a row m minus 1. So, then therefore, we have got total number of rows as 2 into n minus 1. J 2 has got a row of n minus 1, n minus m, and m minus 1. So, then we have got those number of columns have also got 2 into n minus 1. So, J has got also. So, then therefore, our J into delta x is delta m. So, now what we have? Now, we have to define what is J 1, as we have done. J 1 would be delta p by delta E vector. So, then therefore, if we expand them, it will be delta p 2 by delta E 2, delta p 2 by delta E 3 dot 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 delta p 2 by delta E n, delta p 3 by delta E 2, delta p 3 by delta E 3, delta p 3 by delta E n. Then we continue to p n by tau E 2, p n by rho E 3, p n by tau E n. This is the matrix J 1. So, this has got n minus 1 cross n minus 1. So, this is a square matrix. Because it is a square matrix, so it has got diagonal elements is delta p I by delta E I for all I is equal to 2 to n, and off diagonals are delta pi by delta Ej or Ek, where k is not equal to, and off diagonals are delta pi by delta Ek for all I varies from 2 to n, k varies from 2 to n with the rider k not equal to I. So, now therefore, we have to now derive the expressions of these two elements, that is the two general elements, that is one is delta pi by del Ei and another is del dou pi by delta Ek. So, that is what we have to do. Now, to do that we have to now first write down the expression of pi. Now, when we write down the expression of pi, we have already written this expression of pi. So, we again write down this expression pi. So, pi is k is equal to 1 to n Ei into Ek Gik minus Fk Bik. So, we write it again. Now, pi is equal to k is equal to 1 to n Ei into Ek Gik minus Fk Bik, Ei into Ek Gik minus Fk Bik plus Fi into Ek Bik plus Fk Gik plus Fi into Ek Bik plus Fk Gik. So, this is the expression. So, let us again cross check Fi Ek Bik plus Fk Gik and Ei Ek Gik minus Fk Bik. Okay. Now, as we have done earlier, we will separate the term when k is equal to I. So, then therefore, when you separate the term k is equal to I, what I find? So, when k is equal to I, what I got? Ei square into Gii minus Ei Fi Bii plus Fi Ei Bii. So, then therefore, this Fi Ei Bii and this minus Ei Fi Bii will cancel out, and then it becomes Fi into Gii. So, it becomes Fi square into Gii, and here you have got Ei square into Gii. So, then therefore, what we have is we have got Ei square plus Fi square into Gii plus k is equal to 1 to n not equal to I, then this entire expression Ei into Ek Gik minus Fk Bik plus Fi into Ek Bik plus Fk Gik. So, this is the expression. So, now let us try to find out the expression of del pi, easier expression del pi by del Ek. K is not equal to I. Now, when k is not equal to I, so then if I keep on expanding this, remember in this entire expression k is not equal to I in all these expressions. So, when we are trying to do the partial derivative of pi with respect to any specific Ek where k is not equal to I, we would be only getting one element, and that element would be equal to, it is Ei Gik, minus Ei Fk Bik would cancel out plus Fi Bik plus Fi Bik. So, it would be Ei Gik corresponding to this E k, and from here I get F I B I k, and F k and etcetera, they will all cancel out. So, this is for all I k to n k not equal to I. What would be the expression of del p I by del E I? From here we will get 2 E I G I plus k is equal to 1 to n not equal to I. I have got only one E I this. Please remember this E k would never be equal to E I. So, then therefore, this term will not come into picture, this term will not come into picture, but for any A I this term will come into picture. So, it would be E k G I k minus F k B I k. So, this is the expression of del P I by del E I. So, this is the expression of del P I by del E I. This is for I is equal to 2 to n, and this is the expression of del P I by del E k. So, once we have the expression of del P I by del E k and del P I by del E I, so then in this expression, by utilizing this expression we can find out this matrix J 1. So, these are the, so this gives the all expressions of all the elements or all analytical expressions of all the elements of this matrix J 1. Let us go to J 2. What would be the J 2? J 2 would be from this, J 2 would be del P by del F. So, we have got J 2 it is del P by del F. So, it would be again del P 2 by del F 2, del P 2 by del F 3. So, this is the total structure of this matrix J 2. Again we can see that this is also an, we are already seen that this is an n minus n cross n minus n. So, I have got diagonal elements are del P I by del F I for all I is equal to 2 to n, and off diagonal elements are del P I by del F k for all I k is equal to 2 to n with the rider k is equal to not equal to I. So, here also we have to derive all these expressions of del P I, del V I and del P I by del F k. So, del P I by del f k would be from this expression. Now, pi expression if we look at, we have to pick up the elements containing f k. So, we are trying to do this partial derivative with respect to f k. So, one term will come from f k, so it is f I g I k. From here we will not get anything, from here also we will not get anything, and another I will get minus E I b I k. So, one would be f I g I k. So, it would be f I g I k minus f I g I k minus E I b I k minus E I b I k. So, this is the expression. This is for all I k to n k not equal to I. And what would be the expression of? So, this is the expression of the expression of del p I by del f I. It would be, if we look at this expression, one is 2 f I g I I, 2 f I g I I plus k is equal to 1 to n not equal to I. We have to find out the elements with respect to f I. So, with respect to f I we get this, because here f k will not have any value of f I, because it is k is 1 to n not equal to I. So, then and of course, this will have a 0 derivative, this also will have a 0 derivative, because f k will never take the value of f I. So, only partial derivative we will have only from this. So, it is E k b I k plus f k g I k. So, it is E k b I k plus f k g I k. It is E k b I k plus f k g I k. So, this is the case. This is for all I is equal to 2 to n. So, then therefore, this is the expression of So, by this we have this matrix J 2 is also evaluated, because for matrix J 2 this is an diagonal. So, I mean, so for matrix J 2 we can evaluate this diagonal elements by utilizing this expression, and we can evaluate this off diagonal elements by utilizing this expression. So, once you evaluate all these elements by utilizing these two expressions, this matrix is now defined. Now, we come to the other elements. So, what we have got now, J 3 and J 4 would be del q by del, for example, J 3 would be del q by del E, and J 4 would be del q by del F. J 5 would be del V square by del E, and J 6 would be del V square by del F. So, let us first look at J 5 and J 6, because these are easier to complete. So, J 3 and J 4 would be doing a little later. So, J 5 is del V square by del E. So, what would be this matrix? It would be del V 2 square by del E 2, del V 2 square by del E 3, del V2 square by del En. Similarly, del V3 square by del E2, del V3 square by del E3, del V3 square by del En. Similarly, del Vm square del E2, del Vm square by del E3, del Vm square by del En. Now, this is an rectangular matrix M minus 1 cross N minus 1. So, I have got self term. What is this self term? Where del Vi square by del Ei. So, what would be this expression? Please remember that we have got our equation are Vi square is equal to Ei square plus Fi square. So, then therefore, it would be del Vi square by del Ei would be is equal to 2 Ei, right. So, what it will, so this is for I varying from 2 to m. Actually, we should write it little different way, k. K varies from 2 to n and the rider is k is equal to I. So, that therefore, we are only trying to find out del V2 square by del E2, del V3 square by del E3, del Vm square by del Em, nothing else, and that expression would be del Vi square by 2 Ei. And the non self term are del Vi square by del Ek. For k not equal to I, they will be all identical equal to 0, because Vi square is only a function of Ei square and Fi square. No Vi square is a function of Ek, where k is not equal to I. So, then therefore, this particular matrix J5 would be always have only self term, which are very easy to evaluate, which are nothing but 2 into Ei, and all the non self term would be 0. So, we have got this equation Vi square this, and self terms are this, and non self terms are this. Similarly, for J6 is del V square by del F. So, it will also be something like this, that del V2 square by del F2, then dot 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 del V2 square by del Fn, then it will go up to del Vm square by del F2, and it will go up to del Vm square by del Fn. It is also an m minus 1 cross n minus 1 matrix. So, I have got self term, that is del V I square by del F k, right. I varies from 2 to m, k varies from 2 to n, k is equal to I. So, this is equal to 2 f k, or rather we can also 2 f I, it is all the same, it is all the same. And non-self term, del f k, same condition, only k is not equal to I, so it would be 0. Here also I varies from 2 to m, k varies from 2 to n. So, these are the expressions of this J 5 and J 6. You can see that J 6 is also very easy to evaluate. It has also got only the self term, all the non self terms are all 0, because V I square is only a function of f I square, it is not function of f k, any other f k where k is not equal to I. So, then here so far today what we have done, we have first defined what would be the Jacobian submatrices. There will be 6 Jacobian submatrices, J 1, J 2, J 3, J 4, J 5, J 6. We have also defined what are those, what are those submatrices are. And out of these 6 submatrices, we have finished looking at the expressions of J 1, J 2 and J 5, J 6. In the next lecture, we will be looking at the expressions of the other 2 submatrices, and then further we will continue. Thank you.